You know, we use websites and apps for basically everything, but have you ever stopped to wonder what invisible magic is happening behind the scenes to keep them from crashing under pressure? Well, today, we're going to pull back the curtain on the hidden science of digital performance.
Okay, picture this. The moment you've been waiting for. Your favorite brand is dropping a limited edition item, or a massive flash sale just went live. You and thousands of other people are all flooding the site at the exact same second.
You got it in your cart, you've punched in your details, and you hit that final buy button. And then you see it. The spinning wheel. You know that feeling, right? That moment of pure digital anxiety?
And then, poof, the site freezes, times out, or just plain crashes. So what actually happened behind the scenes to cause that collective groan of frustration? That's exactly what we're going to unpack.
The problem, more often than not, is this hidden villain called the data bottleneck. Think of it like a 5-lane highway suddenly squeezing down to a 1-lane country road during rush hour. Except, instead of cars, it's a massive flood of data requests all trying to get through the same narrow point. The system gets completely overwhelmed and everything just grinds to a halt.
So how do you stop this from happening? Well, you go to the lab. We're going to peek inside the world of Dell's performance engineers and see how they don't just guess. They literally build entire systems and then try their best to break them, scientifically, to find and eliminate these bottlenecks before they can ever affect you.
And here it is, their test setup. Now, it looks complicated, I know, but just think of it as a really elaborate obstacle course designed for data. On one side, you've got the servers running the apps. On the other, you've got special servers pretending to be thousands of users all clicking at once. And right there in the middle, that's the storage system they're trying to push to its absolute limit.
Now, the specific system they're putting through the stress test is called Online Transaction Processing, or OLTP. And this is the workhorse technology behind almost every interactive service you use, from buying a plane ticket to making a bank transfer to ordering a pizza. It's built for tons of users, making small, fast changes to data all at the same time.
And to measure performance, they use this key metric called IOPS, which stands for Input-Output Operations per Second. The analogy here is perfect. Think of it as the number of reps your storage system can do at the data gym. The more reps, the stronger and faster your system is. Simple as that.
So, the lab is set up, they know what they're measuring, and now it's time for the main event. The engineers began a series of high-stakes experiments to find the absolute best configuration to max out those IOPS and keep everything running smooth, even under extreme pressure.
Their first challenge was about the fundamentals. See, the storage system is made up of a bunch of physical disk drives. The question is, what's the best way to arrange them? You can set them up to work together for pure, raw speed, or you can set them up for data safety. This arrangement is known as RAID.
They tested the most common configurations head-to-head, and wow, the result wasn't even close. RAID 10, which kind of gives you the best of both worlds, speed and data mirroring for safety, it just blew the others away, hitting over 4,100 IOPS. Meanwhile, the other common setups could barely get near 3,000.
Just how big was that difference? RAID 10 delivered a staggering 48% more performance than RAID 6 for this specific, intense workload. I mean, think about that. Just choosing the right data layout from the very start gives you a nearly 50% performance boost. That's a massive, massive win.
Okay, so they've picked their winning configuration, RAID 10. The next logical question for any growing business is, can we just, buy our way to more speed? Does performance actually go up if you just add more storage hardware?
And the results were just beautiful. Look at this. With one storage array, they hit their baseline of about 4,000 IOPS. With two, it jumped to over 8,000. And with three, it soared past 12,000. The pattern here is incredibly clear.
The takeaway here is absolutely huge. The system's performance scales almost perfectly. Double the hardware, you pretty much get double the speed. And this is the holy grail for system architects, because it means you have a predictable, reliable path to handle growth in the future.
So, they've proven they can get more muscle by adding hardware. But what if they could make the system more intelligent? The final challenge was to tune the database itself to be more efficient, to make it work smarter, not just harder.
The technique they used is called table partitioning. So instead of having one gigantic, massive data table, I'm talking like a 10,000-page encyclopedia with no index, they break it up into smaller, logical pieces. It's exactly like adding tabs for each letter of the alphabet, making it way, way faster to find what you're looking for.
And the results were super impressive. By partitioning the largest, most used table, they saw a 28% reduction in something called data write latency. And latency is really just a fancy word for lag, the time it takes to complete an operation. By going straight to the right chapter instead of searching the whole book, the system just got significantly snappier.
So after running the data through this entire obstacle course, testing hardware layouts, scaling it up, and tuning the software, a really clear blueprint for peak performance emerged. A winning formula, if you will.
And here it is, the engineer's checklist. First, use that RAID 10 configuration for these kinds of random, transaction-heavy jobs. Second, know that you can scale performance predictably just by adding more arrays. Third, make the software smarter by partitioning your biggest tables. And a final pro tip, straight from the data, keep your storage less than 85% full. Leave some breathing room for peak performance.
So, all this lab talk about server racks and IOPS, why should any of it matter to you? How does this stuff translate from a lab in Texas to the laptop or phone that's right in front of you?
Well, it matters because this rigorous, behind-the-scenes engineering is precisely why your digital life just works. It's the reason your banking app completes a transfer in a split second. And it's the reason you can actually buy those concert tickets during a crazy pre-sale without the site completely falling apart.
This quote from the Dell engineers really sums it all up perfectly. Peak performance isn't about having one super-fast component, it's about designing a balanced and optimized ecosystem where the server, the storage, and the network all work together in harmony.
You know, this quest for performance, it never really ends. Engineers solve for these storage bottlenecks, but as technology evolves, new challenges will always pop up. So the final question is, what's the next bottleneck, and how are we going to engineer our way around it?